Today's episode is on timers and time delay relays. They can be as simple as sand passing through an opening, all the way up to and including highly sophisticated electronic timers. There are two major types of timers, and the two types are mechanical and electronics. And within the mechanical, there are purely mechanical and electromechanical. So let's take a look at those. Mechanical timers can range all the way from your wristwatch to your alarm clock to anything that uses a tensioning spring that releases its tension gradually through mechanically linked gears within the device. Electromechanical devices are typically driven by an electric motor and geared to a certain amount of time on a dial. This is an example of that. This is a intermatic timing device, and it is used to time things like lights and watering systems, anything that you would like to have timed on a daily basis. This particular one is a 24-hour timer. It's the timer, and it has a set of off and on switches that do that. There's a wiring diagram there. Line, which is hot, goes to 1. Neutral goes to A, and out to the switch which turns off and on the load is the number 2. See, here's the load, here's your ground, here's your line. It goes here, it goes through a set of contacts in there, and it goes out to the load, then it comes back to neutral. Another electromechanical timer is made by Borg, and it is a 24-hour timer, and it is divided into 15-minute increments. As you can see along the circumference, there are tabs there. Those tabs can be moved in and out to trip the timer. Each tab represents a 15-minute period within the 24-hour time limit. So this is the Borg timer. Number 1, you set the time. As you see, they have arrows turning that direction. So you set the time by turning the time increment to match the hour. This would be 7 a.m. This would be 2 p.m. and so on. And in order to tell the timer to come on, you push the little small tabs here. So with that tab pushed in, at 11:30, it will turn on the output. At 11:45, it will turn off the output. Each one of these represents a 15-minute time increment. Now if we look at the back, there are 4 terminals on here. 1 and 2 go to the motor. This particular one is 230 volts at 50 hertz. And the hertz are important on these mechanical timers because this is a European timer. It is designed for European power because it is 50 hertz. In the US, it is 60 hertz. If you put a 50 hertz on 60 hertz, it will run faster than it should. Now, terminal 3 and 5 go through a normally open contact, so you would bring your power to terminal 3, and then you would put your load on terminal 5. Today I've chosen the Fuji MS4SM timer. It's an electronic timer, and the reason I chose it is because of its versatility. It can give us examples of all 4 of the major types of timers that are used, and it has a very wide range of time increments, and we will go through those as we go. The demonstration will begin shortly, and this is what that timer looks like. It's an 11-pin socket timer. It plugs right into an 11-pin socket, the circular type that we looked at when we did relays. I think you're going to find the demonstration quite interesting, and hopefully you can learn how to set these timers up. Alright, let's take a closer look at this setup for our demonstration. We're going to start with the negative on the hookup. It's here. This is the negative. It goes to terminal 2, which is common for the entire timer. Then it also goes to the input side of the gate, the start and the reset buttons. And it also comes over and it goes to the other side of the lights that we've put in. We've put 4 lights in to demonstrate the position of the contacts within the system. 1 is the contact or source for the number 1 set of contacts. 2 is the timer common. 3 is contact number 1 normally open. 4 is contact 1 normally closed. 5 is the gate signal. 6 is the start signal. 7 is the reset signal. 8 is the contact 2 normally closed. 9 is the contact 2 normally open. 10 is the timer hot. And last but not least is number 11, which is the contact 2 source or common for the second set of contacts. Now, I've laid out a new board here. I've put together a board for you, and it's going to kind of be universal. But this is going to be the reset. This is going to be the start signal. This is going to be the gate signal. This represents contact number 1 normally open. This is contact 1 normally closed. This is contact 2 normally open. And this is contact 2 normally closed. We're only going to use these 3 switches and these 4 lights for this demonstration, but we do have a main power switch down here, and when I flip that on, as expected, the normally closed contacts turn on. Now, let's take a look at the timer itself. Okay, I hope you can see this well. The first thing we're going to do is we're going to show you there's a little tab up here in the corner, and we can change the modes. Right now, the mode it's in is PO, and PO is on delay. So we're going to change that now. Let's see if we can take it to a different one. Okay, now we're on SF, and SF is signal off delay. Now we're going to go to OS, and OS is a one-shot. That's a different type of timer. And then we're going to go back to FL, which is flicker. We will demonstrate that also. We're going to go back to PO, which is time on delay. Now there are other features on this. For example, right now we are in the, well, you can see it a little better. As you can see, we're on the seconds at the moment. All right, if we change that, this is the one. That takes us to minutes. Then if we change it again, that takes us to hours. So we can time in hours. We can also go down to 0.1 seconds, so we can time in tenths of a second. Now, right now, the scale is 0 to 30. And if we're on tenth of a second, that's 30 tenths of a second. So let's go back to, okay, seconds is probably what we're going to want to work with because it's easier to see and it's not going to have to wait too long. It's not too fast, it's not too slow, we can actually see it. Now, let's look at the next feature. Now we can go 0 to 60 seconds. It started out at 0 to 30. Now we can go 0 to 60. We go to the next one. We can go 0 to 6. We can go 0 to 12. And now we're back to 0 to 30. And I think that's where we're going to stay, is 0 to 30 seconds. All right, now, since we're on the one shot, let's power back up. And you can see the power light comes on here. Now, if I turn the start switch, start on, this power light starts to flash. And right now we're set on 10 seconds, which is kind of a long time, but when it times out, you'll see the contact turns on. Now, if I turn that off and hit the reset, we're back ready to go again. Now, I'm going to do that same thing, and I'm going to show you what happens up here. I'm going to turn it back to, let's go back to 5 seconds. That's a more reasonable time to watch. So I'm going to flip the start switch, and it's timing now, and after 5 seconds, it switches over, and you can see that the two normally closed turned off, the two normally open turned on. Okay, I'm going to turn that off, and now I'm going to hit the reset, and that puts it back so it'll start again. Now, if you'll watch, one good thing about this is all you need is a pulse to start this timer. I'm going to flip the switch and turn it back off, but the timer has started, even though it's just a pulse. And after 5 seconds, as you can see, it changes state. Now we'll hit the reset. All right, now let's go to a different setting. That was time on. Now we're going to go to a different setting. Let's go to SF. And SF is an off delay. And let's show you how that works. Let's flip the power back on. Okay, now if I hit the start, as you see, as soon as I hit the start, the output comes on, which means things change. Now, when I turn it off, as you can listen, okay, it starts timing. It will time for 5 seconds, then it goes back to its original state. Now, let's look at that up here. Okay, if I see, immediately the contact comes on, the relay is energized. And then when I turn it off, it will wait 5 seconds, 3, 4, 5, and at 5 seconds, it goes back to its starting state. So it's ready to go again. All right, that's how the time off delay works. So after you turn the switch off, the relay stays on until the time is timed out. All right, let's go to a different mode. Okay, this mode, turn the power off. You'd never want to change this mode with the power on. It's not a good idea. Let's go to one shot. As you can see, OS. And we're still set on 5 seconds. So if I flip the switch, well, first of all, it'd be a good idea to turn the power back on. So the power's back on. You see the power light. If I flip the switch, it starts the timing. And now it's turned off. Now, let's see what happened up here on the board this time. Okay, turn it down, do a reset. Let's look at the board this time. Okay, if I hit the start, as soon as I hit the switch, it turns on. After 5 seconds, it turns back off. And it will only do that once. for each signal that you send out. You turn it on, and it waits 5 seconds, then it turns off. There's no reset necessary on this particular one. Now let's go to the next mode. Let's turn the power off, and we'll go to the next mode. The next mode is going to be FL, I do believe. Yep, so this is flicker. The flicker mode. So if you want to see what the flicker does, let's turn the power back on. Flicker is a little different. When we turn the start signal on, let's watch it up here. It times for 5 seconds, and it changes. Now it'll time for 5 more seconds, and it changes back. Now it will change for 5 seconds, and after 5 seconds it will change back. So that is what flicker does. All right, let's stop it. Now for this demonstration, let's, well actually that continues until you hit the reset. So after you hit the reset, it stops. So you give it a pulse signal and it will continue to flicker back and forth until you hit the reset. All right, now let's go back to, let's turn the power off, and let's go back to this mode, which is PO, and PO is on delay, which is a very good way to do it. And let's go back up to, let's say 10 seconds. And now I'm going to show you what the gate does. Let's turn the power back on. And if I hit start, it starts timing. But if I hit the gate, the timing stops. It is paused. So you can pause the time in the middle. But when you re-engage it and turn the gate off, it takes up right where it left off. So if it left off at 5 seconds, when I turn this off in 5 more seconds, it should change the state. 1, 2, 3, 4, 5. Okay, so this is more or less a pause. It can pause, it can stop the signal, it will stop the timing in the middle and keep the count, which means if it's been 5 seconds when you hit the gate, it stays on 5 seconds until you remove the gate. Once the gate is removed, it will continue. So if you've got it set for 10 seconds and you let it time for 5 seconds and then turn the gate on, the gate will stop the count at 5. When you release the gate and turn it back off, it will continue the count, and in 5 more seconds it will change the state. So now we turn this off, we hit reset, and we're back to where we're starting. So that kind of lets you know the different types of timers and how they operate. Well, I hope this episode has given you some insight into what timers and time delay relays are. Time delay relays are used throughout industry. They are very important. Don't think we could get by without them. Timing is often the only way to make something happen. So try to remember this. It might be a good idea to go back and watch it again. Thanks a lot, and we'll see you next time. This is Uncle Hippie signing off one more time.